So we're given here that QSTV, so this shape on the inside is a rhombus. We're told that PT, so the entire length here, I'm going to outline it, PT is congruent to RT, and the whole goal is to prove this side over here is congruent to this side. Well, what I kind of see is I see some triangles here that I might actually want to work with. Let me see if I can grab a color to shade in here. If you can see here, this triangle right in here, and now this white one right here, if I can prove those two triangles, the white one and the pink one, are congruent, then I can use CPCTC. Well, let's look at what we know about a rhombus, because they told me that it was a rhombus, and there's probably a reason I need to use it. They've already given me a side, so I can't use side, 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 because we're obviously trying to find the third side, so that one's out. I could use side, side, and what goes between them, an angle. That's where the rhombus comes in. Because if you'll notice here in our rhombus, this is called a diagonal. And a diagonal bisects the angles of a rhombus. So that means that these two angles right here are going to be congruent. That's what I need to know about a rhombus. In this particular case is that these two angles are congruent. So what I want to say next is that angle PTQ is congruent to angle RTQ. And the reason is, in a rhombus, the diagonals bisect the opposite angles. So now let's mark it. This is congruent to this. The next thing I need then is I can say that QT is congruent to itself. The reason is the reflexive property. So this is congruent to itself. And I already know from the given statement that this was congruent to this. So technically I could put 3 there to say I already know those two are congruent. Well, because of that now, I have enough information to say this pink triangle is congruent to this white triangle. So number 4, let's do that. Let's say triangle PTQ is congruent. Now let's make sure we line this up. What lines up to the P? R. What lines up to the T? It goes from R to T. And then what lines up to the Q? Q. And why are they congruent? By SAS congruence. Now that I know that they're congruent, I can finally say that PQ is congruent to RQ, and that's because in congruent triangles, the corresponding parts are congruent. Should have gone this way. CPCTC. I was trying to talk at the same time. Corresponding parts of congruent triangles are congruent.